So in this video, we're going to go over a few examples using the formal definition of a derivative. So for the first example, we have f of x is equal to 5x. So what we want to do is we want to use the equation above to calculate the derivative of 5x. So for the first part of the equation, we have the limit as h goes to 0. So then the first thing we want to do is we want to find f of x plus h. So in order to find that, we take the function, and then anywhere we see an x, we replace it with x plus h. So for the function 5x, we just replace the x with x plus h. So that means for f of x plus h, we're going to have 5 times the quantity of x plus h. Then we just have to subtract the original function. So we have to subtract 5x. And now we're just dividing by h. And now we can simplify the numerator here. So we could distribute the 5 to the x and the h. So we're going to have 5x plus 5h. And then a minus 5x. And then the 5x and the minus 5x cancel out. So we just have 5h over h. And then this limit as h goes to 0 means that we have to plug in h equals 0 once we have this simplified. Well, if we plug in h equals 0 now, we're going to get 0 over 0, which is what we don't want because we don't know what the solution is to that. So what we can do now is just cancel out the h's. So if we cancel out the h's, we get 5. So that means that the derivative of 5x is going to be equal to 5. And now we could actually check that using our rules for derivatives. So if we have x with a coefficient out in front of it, the derivative of that is just going to be the coefficient. So derivative of 5x is going to be 5. So this agrees with the derivative using the formal definition of a derivative. So now what about the function x squared? So let's use the formal definition of a derivative for this. So now I want to find f of x plus h again. So we have x squared. So like I said in the previous one, anytime we see an x, we have to replace it with x plus h. So then for f of x plus h, we're going to have the quantity of x plus h squared. And now we're subtracting f of x. So we're just going to subtract the original function again. So we're going to have a minus x squared. And it's going to be divided by h. So now we could simplify the numerator now. So we have x plus h squared. So we could expand that out. So if I expand out the x plus h squared, I'm going to have x squared plus 2hx plus h squared. And then I have a minus x squared at the end. So I have x squared and then minus x squared, so those cancel out. So now on the top I'm left with 2hx plus h squared. So now if I plug in h equals 0, I'm going to have a division by 0, which is what I don't want to have. So what I can do is I could take 2hx and divide it by h, and then the h squared, and then divide it by h. And now if I look at the first term, the h's cancel out. And then if I look at the second term, I have h squared over h. So the h squared becomes an h, and the h on the bottom cancels out. So what I have now is I have 2x for the first term, and then plus h for the second term. So now I'm taking the limit as h goes to 0. So now, since I don't have a division by h, I can plug in h equals 0. So I plug in 0 for h. I'm just going to have 2x. So my derivative for x squared is 2x. So if I go back to the original ways for calculating derivatives, I have x squared. So then I have to bring the 2 down as a coefficient in front of x, and then subtract 1 from the power. So if I do that, I have 2x to the first power, so I just have 2x then. So using our previous rules for derivatives, they agree with the formal definition of a derivative. And then for the last example, let's say we have 3x squared plus 7x. So again, we'll use the formal definition of a derivative. So now I want to figure out what f of x plus h is. So again, anywhere I see an x, I replace it with x plus h. So for the first term, I have 3x squared. So if I'm calculating f of x plus h, the first term is going to be 3 times the quantity of x plus h squared. So then for the second term, 7x, it's going to be 7 times the quantity of x plus h. And now I just subtract the original function. So I have to subtract 3x squared plus 7x. I'm just dividing by h. So now looking at the first term, I could expand out the x plus h squared again. So if I expand it out, I get x squared plus 2hx plus h squared, just like before. And now for the second term, I have 7 times the quantity of x plus h. So I can distribute the 7 to the x and the h. So I have a plus 7x plus 7h. And now if I look at the last term here, I have minus the quantity of 3x squared plus 7x. So I can just distribute the minus sign. So I end up with a minus 3x squared minus 7x. And now, if I look at the numerator, the plus 7x and the minus 7x cancel out. And I can look at the first term here and distribute the 3. So I distribute the 3 here. I'm going to have 3x squared plus 6hx plus 3h squared. And then I have a 7h minus 3x squared left. So now for the numerator, the 3x squared and the minus 3x squared cancel out. So I just have 6hx plus 3h squared plus 7h for the numerator. So again, if I plug in h right now, I have a division by 0, which is what I don't want. So I want to simplify this a little more before plugging h. So what I can do is divide each term by h, just like before. So I'm going to continue the problem up here. So now I'm going to divide each term by h. So for the first term, the h's cancel out. And for the second term, I have an h squared and an h. So the h squared becomes an h, and the h in the denominator cancels out. And then for last term, the h's cancel out. So for the first term, I'm left with a 6x. And then for the second term, I'm going to have a plus 3h. And then for last term, I have a plus 7. So I don't have a division by h, so now I can plug in h equals 0. So if I do that, I'm going to have 6x plus 7 as my final answer. So my derivative that I calculate using the formal definition of a derivative is going to be 6x plus 7. So let's see if we get the same answer using our previous methods for calculating derivatives. So for the first term, we have 3x squared. So we could just use the power rule on that. So we could bring down the 2 as a coefficient in front of x, and then subtract 1 from that power. So we get x to the first power, which is just x. So we have a 2x then. And then the 3 is a coefficient here, so it just stays out in front of the 2x. And then for the derivative of 7x, it's just going to be the coefficient in front of x, so it's just going to be 7 then. So we're going to have a plus 7. So for the derivative, we have 3 times 2x, which is 6x, and then plus 7 here. So my answer is going to be 6x plus 7, which agrees with the formal definition of a derivative.